Welcome to the deep dive. It's great to have you with us today.
Yeah, thanks for having me. We've definitely got a lot to cover.
We really do. We've got a fascinating stack of sources in front of us and a very clear mission. We're looking at a brand new release from March 10th, 2026.
Detailing the EON Genesis 3.0 platform.
Right, which is also sometimes called the Babylon engine. Our sources today are a recent press release and a really detailed white paper.
Titled Mastering EON Genesis 3.0, a step-by-step guide to your training ecosystem.
Brought to us by EON AI Ventures and EON Reality. And I have to say, it is a pretty dense read.
Oh, absolutely. It's a hefty stack of documentation. It's heavily focused on enterprise architecture, 3D modeling frameworks, and artificial intelligence integration.
There is just a massive amount of technical ground covered in these pages.
Which brings us to our goal for this deep dive.
Exactly. We know your time is valuable. You don't need us to sit here and read a software manual out loud to you.
Nobody wants that.
No, they don't. So we are cutting straight to the core. We're slicing through the corporate jargon to focus strictly on the most critical, game-changing key points of this document.
We are going to explore what makes this technology tick and how it actually works in practice.
And most importantly, why it matters to the future of how human beings learn complex skills.
That last point is really the anchor for all of this. I mean, the technical specs are impressive, but the implications are massive for literally any organization that relies on highly specialized physical skills.
To really grasp why this technology was built, I want you to imagine a scenario.
Okay.
Imagine you have just been hired for a high-stakes job. You have to learn a highly dangerous, incredibly complex industrial task.
Like operating a multi-million-dollar piece of heavy machinery.
Yeah, or maintaining a high-voltage power grid, or dealing with volatile hazardous materials. Now imagine your supervisor walks in and hands you a flat 100-page PDF document.
And maybe points you toward a break room to watch a generic, badly lit training video from 5 years ago.
Right. And once you're done reading, they just point you to the actual machine. How confident are you feeling about not destroying the equipment?
Or worse, severely hurting yourself.
Exact.
I would venture to guess your confidence is sitting right around zero. And frankly, it should be. That is a terrifying scenario.
But ironically, it's the reality for countless technical roles around the world right now.
That disconnect between reading about a dangerous task and actually performing it is precisely the problem we are exploring today.
We are looking at how AI-powered, immersive 3D environments are trying to completely eliminate that dangerous learning curve.
Turning flat, static documents into performance-ready, interactive educational worlds.
Okay, let's unpack this.
Yeah.
Because to understand why EON Genesis 3.0 exists,
Yeah.
we have to look at the massive ticking time bomb outlined right at the top of their white paper.
They frame this as a literal crisis for the global economy, and the data they cite backs that up entirely.
According to their research, 50% of the currently skilled workforce is expected to retire within the next 5 to 7 years.
50%.
We aren't talking about a gradual shift. We're talking about half of the experts walking out the door.
What's fascinating here is the sheer, terrifying scale of that brain drain. When we talk about workforce turnover, we usually think about filling empty desks or updating HR policies.
Right.
But this is a massive existential knowledge transfer issue. Think about the individuals making up that 50%.
These retiring workers hold decades of highly specialized practical muscle memory expertise.
They know the exact sound a turbine makes right before it overheats.
They know the precise sequence of valves to turn in a chemical plant to prevent a pressure buildup.
And companies are looking down the barrel of this 5 to 7 year timeline, desperately trying to figure out how to capture that localized expertise.
Before the individual holding it literally walks into retirement and takes it with them forever.
And their first instinct naturally has been to throw basic artificial intelligence at the problem.
But the white paper points at a massive friction point with that approach, something they call the precision gap.
Yes. The data indicates that generic AI generation and basic digital training content usually deliver only about 80% of the required results.
If we connect this to the bigger picture,
that 80% metric is exactly why traditional off-the-shelf AI training is failing in these specific industrial environments.
Look at it this way. In an average office job, if an AI drafts an email or a report and it's 80% accurate, that is a massive win.
You tweak a few sentences and you send it off. It saves you time.
But in high-stakes operations where precision and human safety are paramount, companies absolutely demand 100% confidence.
Because falling 20% short on an industrial safety mission isn't just an
It's
inconvenience.
not a typo in a spreadsheet.
That 20% gap is where catastrophes happen.
Yeah.
Falling short in a high-voltage maintenance scenario or an aerospace manufacturing facility means severe compliance violations.
Millions of dollars in lost productivity.
And most importantly, critical safety hazards. You simply cannot afford a 20% margin of error when training someone for a hazardous mission.
EON AI Ventures specifically built this platform to bridge that exact gap between generic, good enough learning tools and the infallible precision required by the enterprise sector.
So we know the stakes. The entire goal is to digitize the brain of a retiring expert and turn it into an interactive 3D training module. And it has to be perfectly accurate.
How do they actually do that? This is where the white paper introduces EON Genesis 3.0 as the solution.
They describe it as an AI-powered platform designed to redefine the enterprise training ecosystem.
The overarching promise is that it combines intelligent content generation with highly immersive simulation environments to rapidly turn human expertise into a structured, scalable system.
To appreciate how they achieve this, we need to look at how painful this process usually is. For most enterprises trying to build interactive VR or AR training tools today, the process is agonizingly slow.
It's labor-intensive, the software is fragmented, and it usually requires a dedicated team of software developers.
Just to align procedural training steps with 3D graphical assets, Genesis 3.0 is built to accelerate and standardize that entire creation lifecycle.
Let's follow the journey of how a module is actually built, starting with what we can call step 1, the canvas.
The architecture refers to this as the scene editor.
Instead of requiring you to write thousands of lines of code to build a virtual room, they provide a robust 3D workspace. The engine driving the visual workspace is built on something called Babylon.js.
For those who aren't software engineers, how should we understand what that is actually doing for the user?
Babylon.js is essentially a highly powerful invisible physics and rendering engine that operates directly inside a web browser.
It's doing all the heavy mathematical lifting behind the scenes.
When a user is in that 3D viewport, panning the camera around, zooming in on a microscopic component, or orbiting a massive piece of machinery, Babylon.js is what ensures the rendering is smooth
And responsive without requiring the user to download massive, cumbersome software packages.
And inside that workspace, you organize scenes using a left panel, manipulating what the system calls meshes. You drop your 3D model in, and the system automatically organizes its parts into a searchable hierarchy.
You aren't just looking at a flat picture of a car engine. The system recognizes the engine block, the spark plugs, the belts.
All as individual digital components or meshes that can be manipulated.
It forces a very structured approach to building a fully interactive environment. You are effectively laying out the exact component-by-component digital replica of the equipment the trainee will eventually be working with in the real world.
Here is where it gets really interesting. Let's say I drop a complex 3D model of a control panel into this workspace. It has 50 different buttons, levers, and dials.
In a traditional workflow, you would have to manually code the behavior for every single one of those 50 components.
I'd have to tell the software, when the user clicks this, make the lever go down. EON Genesis does not ask you to do that. Instead, it features an AI interaction suggester.
This is arguably the most transformative feature in the entire pipeline. The AI interaction suggester doesn't just look at the code. It actually analyzes the physical geometry of the 3D objects and the broader context of the scene.
It evaluates a digital object and immediately suggests the appropriate real-world physics.
It recognizes a valve and suggests a rotational interaction. It recognizes a slider and suggests a linear pull interaction.
But wait, how do we know it isn't just taking wild guesses? If it thinks a push button is a rotational dial that breaks the immersion immediately.
The engineers built a transparency layer into the AI. It does not just blindly apply these physics, it provides the creator with confidence percentages.
It gives you a clear metric indicating how certain the AI model is that a specific interaction matches the object's real-world functionality.
And to make the workflow incredibly efficient for massive industrial models, organizations can use a bulk apply all action.
The AI will instantly assign these physical interaction behaviors across hundreds of components simultaneously.
That saves an unbelievable amount of development time. We have gone from months of coding to a few clicks.
But we have to address the context of the learning. So far, we have a highly interactive machine, but if it's just floating in a blank white virtual void, that doesn't exactly prepare a worker for the sensory overload of a real factory floor.
how are they making the environment itself feel authentic?
The white paper details an environment tab that tackles this exact issue. While they offer adaptable 3D presets for generic industrial or lab spaces, the most critical technology they highlight is support for Gaussian splats.
I have to pause you there because Gaussian splats sounds like something out of a 1990s sci-fi movie. What is that, and why does it matter for a trainee?
It sounds esoteric, but it's a massive leap forward in visual realism. In the past, if you wanted a trainee to practice in a virtual replica of your specific chemical lab, a 3D artist had to painstakingly draw and model every single pipe, floor tile, and piece of equipment by hand.
It was incredibly expensive and often looked like a low-resolution cartoon.
Gaussian splatting uses advanced AI to take regular 2D video or photos of a real physical space, like your actual research-grade cleanroom.
And it instantly generates a photorealistic, fully navigable 3D environment from that footage.
So the trainee isn't looking at a cartoon representation of a generic factory. They are standing in a photorealistic digital twin of the exact room they will be working in next Tuesday.
And for the learner, that visual context is everything. When the virtual environment perfectly matches the lighting, the layout, and the scale of the real world, it dramatically accelerates time to competency.
The brain registers the training as a real memory, rather than a video game exercise.
That is incredible for immersion. But I want to play the skeptic for a moment and circle back to a massive liability issue we touched on earlier.
You mentioned the AI interaction suggester can use a bulk apply interaction to instantly map physics and behaviors to hundreds of parts on a machine.
If we're dealing with high-stakes, hazardous environments like a nuclear control panel, isn't that dangerous?
What if the AI gets it wrong? Falls into that 20% air gap and teaches a trainee to push a button that they're supposed to pull?
That is the multi-million-dollar question, and EON's architecture explicitly answers it. They do not allow the AI to operate unchecked.
The solution to that 80 versus 100% dilemma is found in a vital safeguard they call the auto-config review.
So there is a built-in safety net. How does it function?
Think of the AI as an incredibly fast, eager intern doing all the heavy lifting and the human expert as the senior editor.
Before any of the AI's interaction logic is permanently applied to the training steps, it routes through the auto-config review.
This generates a comprehensive configuration summary. The human expert, perhaps that veteran worker who is about to retire, reviews a logic that links the 3D components with the procedural training steps.
They aren't building it from scratch. They are just verifying the AI's homework.
Precisely. They are given strict approve or reject controls. They can accept the correct settings or flag and adjust errors before the logic is finalized.
This human-in-the-loop mechanism guarantees that the final module achieves that required 100% accuracy.
It completely eliminates the liability of a hallucinating AI teaching someone the wrong safety protocol.
That completely shifts the role of the retiring expert. Instead of struggling to learn how to code a 3D environment to pass on their knowledge, they can just spend their final months reviewing and approving the knowledge the AI has structured for them.
It respects the expert's time and focuses their contribution purely on quality assurance and domain knowledge, which is exactly where their value lies.
Let's look at how an organization actually manages all of this at scale.
The white paper details a centralized dashboard that operates as the command center for this entire training ecosystem.
It features a stats overview tracking progress and something they call training recipes.
I love that phrasing. It makes me think of those meal kit delivery services, but for enterprise knowledge.
The meal kit analogy is actually perfect. A recipe implies a standardized, repeatable process.
They aren't treating each training module as a bespoke artisanal project. They are creating templates, recipes that provide the exact digital ingredients and structural steps required to build a standard safety protocol or an equipment maintenance guide.
It ensures consistency across a massive global workforce.
And when it comes time for the actual employee to take the training, the dashboard features energy training missions.
These missions use color-coded difficulty badges and strict mission priorities. It gamifies the experience just enough to ensure the trainee knows exactly what sequence of skills they need to tackle first.
But the final piece of this puzzle is access. Once this incredibly accurate, photorealistic, AI-generated module is approved and assigned, how does the trainee actually experience it without needing a $10,000 supercomputer?
The architecture solves the deployment bottleneck through comprehensive WebXR capabilities.
For our listeners who might not be deep into the spatial computing world, what does WebXR unlock for an enterprise?
In the simplest terms, WebXR bridges the gap between the web browser and virtual or augmented reality headsets.
Historically, deploying a VR training module meant forcing IT departments to install massive custom software applications onto thousands of secure employee devices.
It was an administrative nightmare. WebXR allows the trainee to simply click a web link, put on a standard VR or AR headset, and immediately enter the lifelike real-time simulation.
No massive downloads, no complicated software licenses on the user end, just instant access to a hands-on problem-solving experience without any of the real-world physical risks.
It completely democratizes access to the training. Whether a worker is at headquarters in New York or at a remote mining facility in Australia, as long as they have a headset and a connection, they can step into the exact same verified, immersive environment.
It really is a comprehensive end-to-end ecosystem, and to understand the weight behind this specific platform, it's worth looking at the enterprise context of the organizations that built it.
The documentation provides some crucial background. EON Reality brings over 25 years of experience as a global leader in augmented and virtual reality-based knowledge transfer.
That quarter-century of experience is a massive credibility marker in an industry flooded with overnight startups.
They aren't guessing at what industries need. They've been navigating the friction points of enterprise immersive learning for decades.
They understand the difference between a flashy tech demo and a scalable enterprise solution.
And to accelerate this specific AI integration, they partnered with EON AI Ventures, which was established by the same leadership team.
EON AI Ventures operates two major platforms to scale this globally. They manage the enterprise AI platform, which supports broad operational intelligence.
And the virtual campus, sometimes referred to as the virtual compass, which provides the infrastructure for scalable certification and knowledge transfer across governments and educational institutions worldwide.
It underscores a very specific mission. Unlike generic consumer AI tools that are trying to be everything to everyone, this architecture is explicitly engineered for environments where precision, scale, and safety are the only metrics that matter.
I think Dan Lajerskar, the chairman of EON AI Ventures, sums up their ambition perfectly in a quote from the release.
He states that Genesis 3.0 represents a pivotal moment in enterprise training where advanced AI merges with immersive 3D environments to create unparalleled workforce transformation.
He emphasizes that by focusing strictly on interactivity and measurable outcomes, they are empowering organizations to exceed the needs of an AI-driven future.
It is a sweeping statement, but based on the workflow we have just dissected, from the AI interactions suggested to the Gaussian splats, all anchored by the auto-config review, they are systematically eliminating the exact technical bottlenecks that have bottlenecked spatial training for years.
So what does this all mean for you?
If we synthesize everything we've explored today down to one core takeaway, it is this. As the skilled workforce rapidly ages out and takes their generational knowledge with them, the era of flat static training is officially over.
Handing a new worker a PDF to learn a dangerous job is no longer acceptable.
The future of learning complex high-stakes tasks requires instantly capturing human expertise and transforming it into scalable, highly immersive, and 100% accurate 3D simulations.
The companies that thrive in the next decade will be the ones that digitize their experts' brains before they retire.
This raises an important question, and it is something I want to leave you to ponder long after we sign off.
If platforms like Genesis 3.0 can perfectly digitize, simulate, and visually verify the operational expertise of a retiring master technician, what happens to our fundamental concept of experience itself?
In 10 or 20 years, will we still place a premium on a human worker's hard-earned physical muscle memory?
Or will we strictly value the AI's ability to perfectly replicate the very best version of that memory in virtual reality available for anyone in the world to instantly download and practice?
That is a staggering thought to end on. The idea of downloading a 40-year career's worth of muscle memory through a WebXR headset.
It really is.
Thank you so much for joining us on this deep dive. We hope we helped cut through the noise and brought you the key insights you need to understand where the future of training is heading. Keep questioning, keep exploring, and most importantly, keep learning. We will catch you next time.